Hello everyone. So today we are gonna try RAG operation by using Llama-Parse mechanism of insurance data. Okay. So first let's understand what is the data we have, like the document. So in this case you can see this is the document of policy hub by the government of India, and here there are several things regarding the policy. You can ask question regarding that and so many things, like as the RAG operation works. I hope you better know how RAG operation works. If not, let me know in the comments. I will explain in the later videos. Okay, so let's see the data right now. You can see in this data there are some tables. Okay, so for tables, if we parse the data by using any other method other than LlamaParse, it won't consider table as input. It will convert everything to text and then it will give result based on that. So that is not correct, because we need the information inside the table as well. Okay, so for that the Llama-index has come up with the LlamaParse mechanism, in which we can convert everything to markdown language, and then that markdown language can be utilized in form of information retrieval generation. Okay, so let's start with this. So first we have to install Llama-index as well as LlamaParse. So let's run it. So it will take a little bit of time to install everything, and if you want to run, you don't have to click every time. You just have to click shift enter and that cell will run automatically. Okay, so here you can see everything is run and we have installed the dependency, which is Llama and Llama-index and LlamaParse. Okay, so let's paste the documentation, which is the government policy holder government.in, and once you run this, it will download in your local and you can see here. So it will come here as a policy.pdf. So you have the policy in your system. Now let's initialize Llama-index and LlamaParse for nest async cryo, so that it will async first and then running the sync code in the notebook. So it needed a async IO. So in this case it will use nest async IO. Okay, so let's import it, and now we are initializing it. Now let's give our environment variable, which is the API key of Llama Cloud API as well as OpenAI API. Okay, so if you want to know how you can get the Llama Cloud API, you just have to go over the browser, search for Llama-index cloud, and then in Llama-index cloud you can, for Llama Cloud, you can go there and create your API key. If you want to understand how that works, how we can create one API for our purpose, let me know. Yeah, I will create a video out of that. So yeah, we have initialized our environment variable. Now let's import the necessary libraries to do a RAG operation. Okay, so first the important thing is Llama-index OpenAI. So let's import from. Now we have to import the embedding models to do embedding of the PDF. Let's copy and paste it here. Why we are wasting time? So we have imported the necessary libraries for our use case. For example, this is the OpenAI for question answering of the RAG operation, and second one is OpenAI embeddings, which will be used for that PDF file, and that PDF file will be converted into text and embeddings later on. And then this is a vector store we have imported. The vector store will store the embeddings and the settings to use these kind of variables, for example Llama Cloud API as well as OpenAI API key, so that it should be secured. We should not put these kind of things here. It should be in .env file, but here for easy use case we have put it here, but you won't be able to see these things, right? Yeah. Okay, so after this we have to initialize our embedding model, LLM and settings. Okay, so let's do it. So in this case we will use text embedding 3 small, okay, by OpenAI. And it should be 3, not E. Okay, and for LLM we will use OpenAI's GPT 3.5 Turbo. Okay, and let's initialize our settings. So that is, so it will take the settings for this environment variable and it will use in this LLM. Okay, now let's do the old way, how we can parse the document without without using any specific kind of instructions. Okay, so this is the in vanilla method which we are trying right now. So here we are mentioning that our result type is markdown, so that it won't take as a text. Okay, so there are only two types which is right now available in LlamaParse, so that is text as well as markdown. You can try with text also here in this case. So I have initialized and it will take a small time to run these things. Okay, yeah, it's run. Now let's print our document and let's see how it behaves, and if there is any table, how we can see the table. Okay, and how it looks. Okay, let's print it. You can see these are the tables. So as we write the tables in markdown, it is showing in that way only. Okay, that markdown, the double hash, it should be highlighted things. Okay, h2 and h1 as HTML tag. Okay, so it is looking like it should, how it should be. Okay, next is how to use that node parser and what the node parser does. Okay, so our markdown element node parser works well for passing markdown output of LlamaParse into set of tables and text nodes. Okay, so let's try this. So yeah, this is the importing of this markdown element node parser, so that we will know that we have used the markdown element and then we are passing the model, that is LLM, and we are using number of workers as 8, so that 8 nodes will work at the same time. Now let's write node equals to node parser dot get nodes from document. Yeah, you can see nodes from document and the document which we have done earlier. So if you pass this, it will take some time to understand the node as well as the processing of that node. So in this case it will use 8 workers to do task faster. Yeah, it is done. Now let's initialize the base node, an object and recursive index, and in this case we will create our embeddings and store into vector store. Okay, so let's do it. Node parser dot get nodes and object, and then here we will pass nodes which we have initialized just now. Spelling is wrong. So pass node and then it ran. Okay, now let's create a recursive index for vector store. Vector store index, and here we will pass node. Okay, nodes equals to base node plus the objects. The base node and object will pass here for vector store, and here it will create a recursive index for the same. Okay, now let's create a query engine for that recursive engine. So query engine equals to this recursive index dot as query engine, and here we'll pass the similarity top k, and the value is 25, and here you can pass any values, for example 5, 10, 20 based on your use case. Okay, so let's run this query engine, and here it created the query engine. since we are using ChatGPT API, so OpenAI API, so in this case the things will become very fast. But if you want to use in your local LLM, please do let me know. We will create a video for the same, and it will definitely work for that case also. But for our for our easiness, we are using this kind of approach by using OpenAI API. So let's write one query. So my question is, my trip was delayed and I paid 45. How much? So in this case 45 is 45 rupees or $45. Okay, we can change based on the information, but right now for convenience we have written like this: how much I cover for. And so this is a question, and let's ask this question to RAG system, which we have developed just now. And here we will pass the query, which is this query. So better keep it name as like this, query underscore 1, and this will be response number 1. So yeah, it will generate the response, and let's print the response. So in the Colab notebook, you don't have to write print statement every time. If you want to print in the new cell, you just simply write the variable name and it will print that particular variable. So here the result is like this: you are covered for the expense and something. So there is embedding notes and so many information which are there. Let's print the response. Okay, so this is the response which is there: you are covered for the expenses incurred on alternative travel. And this is the response, which is not bad, but it's not that good, because I am asking about the $45 or 45 rupees, and here in this case it is not even mentioning these things. Okay, so they are just taking the clause from the PDF and giving me the response. Okay, so now let's ask the question which is not there. Okay, so let's create a information document with instruction. Okay, so let's paste it here. Okay, so you can see this is the document with instruction, and here we are passing the LlamaParse. Here is the result is marked down as we have initialized earlier. If you can see here, so here you can see there is only one thing which is there: the result type is marked down. But now we have used this parsing instruction, and this is the parsing instruction. It will now know what is this document about, and then based on the document's information it will generate the result. Okay, so in this case the prompt is something like this: this document is an insurance policy. When a benefits, coverage and exclusion is described in a document amended to it and added text in the following benefits string format, where coverage would be exclusion for name of risk, and in this condition when does the coverage apply is the coverage is and the coverage description. Okay, if the document contains a benefit table that describes coverage amount, do not output it as a table but instead of list of benefit in a string format. Okay, so this is the prompt which we have given as a parsing instruction, and let's see how it behaves for that particular approach. So now let's print the document which we have printed earlier. Here, this is right. Let's copy it. Okay, let's not do that. Let's not print these kind of things. Let's print another thing. Okay, so for example, the target page is 45, and for vanilla approach, let's write vanilla pages in vanilla. We use documents, right? So documents and this dot and text as we have written earlier for print statement, right? Dot split. So right now we will split based on this slash n dash 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 and then again slash n. So this is the vanilla. Now let's write the document with instruction page. Okay, page with instruction, and this is the page with instruction. And now we'll copy this document with this instruction and paste it here. Sorry. And here we'll pass the same thing as above. So just like that. Yeah. So now we have initialized the two things, and now print both of those. Okay. So print page vanilla, and in this page vanilla we will pass the target page, which is the 45 number page. I will show you how 45 page looks like in PDF and how it looks like here. So print again, and this is the separator, and now print this. Let's see first how page 45 looks. So this is the page 45. Everything is in table format. Okay, everything is in table format, and these are the locations, addresses and everything. Okay, let's print it here. In both of the cases, let's see how it looks. List object has no, okay, we have to call it into a list, into square bracket. Sorry, my bad. List object should be inside this. Let's run it. Okay, so as you can see, in the first case it is showing similar as before. Okay, and for this with instruction, it is getting the response like this for inpatient treatment and this condition, when does the coverage apply and have claim and something like that. So it is totally different. Okay, it is totally different. As you can see, we have put a separator and the things are totally different. Okay, so now let's ask question and see how the questions are the same but response are different. Okay, for that we first we have to initialize the node parser, and as before. Okay, so I have put it the same way as before. Instead of parser instruction, it is node parser, it is node parser instruction. Nodes instead of nodes instruction. So we have changed the variable names so that both should be different from each other and give the response accordingly. Okay, so let's run it, and it will take a little bit of time, but it will instantly run it. Now let's ask the same question what we have asked earlier. So this was the query. Okay, so this was the query and we were asking the response. So it was the response. Okay, now let's print vanilla response. Okay, and this was the response, which is response 1. Fine. Now let's call it the other way, the other one, which is the not vanilla one, which is the with instruction. Let's do it. So for that, response 1 and with instruction, that is I equals to query engine instruction, which is this dot query and the query one. Okay, and let's add print, and here we'll write instruction and the response one I. So if you print this, you can see the difference between those two. Okay, so this is the output, and you are covered for the delay for your trip as a sum insured and mentioned in the certificate of insurance. You are covered USD 40. So right now the response are kind of same. Let's run it again, but the response was more precise and proper. Okay, so here in the vanilla approach, it said that you are covered for the expenses incurred for an alternative travel booking under any mode of transportation up to limit of the sum insured mentioned in the certificate of insurance, and here it is mentioning that particular point only. Okay, so in previous, okay, now let's ask another question. Okay, so here we'll add everything like this. Okay, and now the query will be, I just had a baby. Is baby food covered? Okay, so it is a generic question. I just had a baby. Is baby food covered in the insurance? Okay, let's run it and see the response of both of those. So for vanilla, it is written like this: baby food is not explicitly mentioned as cover benefit in the provided context information. The coverage details primitively focus on medical treatments, hospitalization, emergency, and so many things are written. There are so many information for that particular question. But if I talk about with instruction, in this case the answer is precise and short. Okay, so baby food is not covered under the insurance, and that's it. We just wanted to know that is baby food covered or not. We don't want all of those information as vanilla is giving. Okay, now let's ask question 3. Okay, the question 3 will be, okay, how is gauze used in my operation cupboard? So let's ask this question. How is gauze used in so that is the question. Let's ask the third question, which is I fell from a building and EDMI admitted to hospital. How much coverage I will get? Or let's ask this question. Okay, so vanilla response is, you will receive coverage under the emergency in partial medical treatment benefits of the expenses incurred on the treatment, and so many things are there. But if I talk about this, you will receive a coverage under personal accident coverage section in the insurance policy. So that is a kind of accident, so it is correct in this case. Okay, and section policy, the coverage amount will depends on the specific condition you meet as mentioned before. Okay, in the table 1 of policy. So it is not showing the particular result or particular table, but it is mentioning we can see in the table 1 of the policy, and the coverage will be based on the severity of the injury that we had. Okay, so this is the correct response. That is not incorrect, but it is more precise. Okay, so that's it for today. If you have any questions or any suggestions for me to create a POC for any of the operations or any of the things which is a part of LLM or anything related to AI, just let me know in the comment. I will definitely make a video out of it and make sure you will get the full of that. Okay, thank you so much for your time.